Let's start off with 21 and 22. The other class was really having troubles with that. They're like, oh, you never went over it and that kind of thing. And you're right. I never went over exactly one of these problems. But it's actually very easy. Okay, now I know what you're going to say. I say everything's easy, but I'm telling you. 21 and 22. And same with, what do you know, 25 and 26, right? Aren't they the same? Yeah. All right, so let's take a look real quick. I bet you anything, when we're finished with this, you'll say, yep, Mr. Hamrick, you're right. It was easy. So let's take a look. 21. Let's do 21 first. So 21 said, I gave you two equations of a line. It said y equals -2 and y equals 4. All right, those are your equations. That's an equation of a line. Well, we talked about this. We didn't spend a whole lot of time on this. Actually, the stuff that you just took a quiz on today, it was covered in those sections, right? One of those, I forget which one, 3 or 4, whatever. But what kind of a line is it when it's just y equals a number? It's a horizontal line, right? It goes through the y-axis. Here's the y-axis right here. The line goes through the y-axis at that particular number. Okay, that kind of looks like a 4. Let's make it look like a y. Okay, so watch. Y equals 4. 1, 2, 3, 4. All it is just a horizontal line that goes through +4 on the y-axis, and I'm going to put a -2 down here. So we've got a 4 right here, we've got a -2 right here, and let's just change the color of the line, make it red. Oops. I always do that. Well, it's when I tap. When I have it on the line tool and I tap, sometimes I'm like moving it around and pointing and I accidentally tap it. I didn't want to, but it'll look, oops, like this. Alright. And then here's another one right here. So here are the two lines. You with me so far? Okay. So now let's just change this to a different color. Not that you can see the difference on the screen, but it's good enough. Here we go. What are we trying to do? What do the instructions say? Find the what? Distance between each pair of parallel lines. When they're horizontal or vertical, it's actually very, very easy. Okay. We're not assuming anything. I would say, yeah, I would say if they put on a graph and it, yeah, I would say you could probably, there are a few assumptions you can make, right? Like a line is always straight. Anytime you see a line, if it looks straight, don't think that it breaks right here and goes off like at, you know, like 0.001 degrees. You know, how do you know it's not? You know, I've had people say that. If it looks like a straight line, it's a straight line. Okay, that's one assumption you can make. And yeah, if they graph it, and they didn't graph these on here for you, but you know, just looking at this is a straight line, or it's a horizontal line, I should say. Now let's talk about this. I could take any point on this red line, I don't care, let's take it from here, and I'm going to go perpendicular, right? So I want to find the distance, this is blue, the distance of this little blue line right there. I could take from any point and go perpendicular, it's going to be the same distance. You already see it, don't you? What is it? You're at 4, you go to -2, how far is that? That's just 6, so the distance is 6, that's all you do. You just subtract those two from each other. Yeah, really simple. You with me on that? You could have done some stuff where you did distance formula, but did you need to do that? No, not at all. All right, 22. Now, was I right? I wasn't lying to you, was I? About it being easy, was I? No, it was definitely easy. Yeah, I know. We'll get to 23. That's definitely... but I'm saying 21, 22, and I think 25 and 26 were the same kind. Let's just do one that's vertical this time, just to show you that they're kind of the same. This is 22. So 22 said x equals 3 and x equals 7. Alright, so watch. I'm not even going to mark them off. That's 7 and that's 3, right? So what kind of lines are these? They're vertical lines. When it's x equals a number, they're vertical lines. Alright, so here's your two lines, and what are we trying to do? We're trying to find the, what? Distance between them. So let's go with the color again. So I can pick any point on this red line right here, and it has to be perpendicular, right? Now, what's perpendicular to a vertical line? A horizontal line, exactly. Okay, so if I'm at 7 and 3, what is the distance right here? It's just 4. There it is. That's all you had to do. Absolutely. Yeah, what I just did right here, it's exactly what you could do. All right? That's it. So that's 4 of those problems. What did I give you, like 9 altogether? So that's almost half of them, right? Okay. Yeah, I understand the other one's a little more difficult than these. But a lot of people in the other class didn't like this stuff because I didn't do it exactly this way in class. Right? Oh, it is much easier. Well, that's what I'm saying. That's what everybody else was complaining about is, Mr. Hamrick, you didn't do one like it in class. How are we supposed to know how to do it? But if you just graph it, look at it, understand that this is horizontal, understand that that's vertical, understand the distance is the perpendicular line between them, then you should be able to just look at it and tell, right? Even though I didn't exactly do that in class, I gave him a big speech today about in Algebra 1, they basically just teach you how to do a problem, and then you just rehash everything that you did in class, right? They hardly make you even think too much in Algebra 1. Now, in geometry and starting out in Algebra 2, you have to start thinking a little bit, and I don't give you an example for every single problem that you're going to do. You have to take some of the concepts that I give you, right, some of the principles that I teach you, and then just apply them yourself. Okay? Yeah, that's fine. If you understand what's going on, okay? But the whole reason I graphed everything so everybody could see why, you know, the distance is what it is. We good with that? All right. Now let's do one that's a little bit more challenging.